Get started. I first apologize for the delay in getting started. Let's leave that machine there. I have a hope that it'll come back. No, let's give it some time. Yeah, just in case it comes back up, I'll use it. Otherwise, we'll run with this. Thanks. So let's get started. We're going to kind of recover along the way and see how we can do it. But let's get started. So what I want to talk about here today is about picking a JVM language. Now, if we let's talk a little bit about why do we want to do that, and then we'll talk about some of the ways we can approach it. So the very first thing is Java was predominantly the language on the JVM. Let's kind of reflect back on where we started with. Back in 1994, around that time, we had Java language being introduced. And of course, there was a lot of excitements about around Java, and Java being a language that brought in automatic garbage collection as a fairly effective technique. It's been around for a while. Java is not the language that introduced automatic garbage collection, but certainly that came about to be kind of a standard practice, if you will, along the way. And as we got excited about using Java and Java slowly became mainstream, what has happened over the past about 15 years? If you look back in time, Java really had three major parts to it. The Java language, definitely. We also have the JDK, Java Developer Kit, and we also have the Java virtual machine. And if you look back at the past 15 years, what's happened is that the JVM has become only stronger. It's probably one of the most predominant platforms out there, very high performant, fairly stable, and really effective. The second thing, of course, is the JDK, and the JDK is very versatile, and look at all the number of libraries and functions and classes and various solutions we have on our hand, makes our life a lot easier to develop web applications. But what about the Java language, though? And I would argue that the Java language, as time went on, turned out to be the weakest link. And if you really look back at time as to how Java has evolved, the last significant language change was in JDK Java 1.5. Now clearly Java 8 looks very exciting, very promising, but that's been a real big gap between the time Java has evolved. The previous big change was in Java 1.1, and then the next change was in Java 5. And what did Java 5 really bring about? We had generics, for example. Of course, we had auto-boxing and a few other features. Java 6 really did not have any language feature at all, and Java 7 really did not have any notable language feature. Now, Java 8 looks very promising, but ignoring that for a minute, in the meantime, there has been several other improvements on the JVM, on the Java platform rather. So Java, rather than being a language, has turned into a very powerful platform over the past about 15 years. So given this, there are other languages that started coming up on the JVM starting about 2003 timeframe. So we have languages like Groovy, languages like Scala, Clojure, JRuby. Well, if I have to start naming it, we'll be here for a very long time. There are over 200 languages on the JVM actually. With 200 different languages, does it mean we have to go and look at, and I see a few people already scared right now, I'm not going to talk about 200 languages today, but with 200 languages out there, do we have to look at all of those? Well, it turns out that the languages can be kind of grouped together because there's a lot of commonality between a lot of these different languages. We'll talk about some of those here today as we go through some of the concepts that we're going to look at. So essentially the point really is that starting about 2003 timeframe, we've had a few languages constantly appear on the JVM with different capabilities and features. Now, if we are programming applications, we could be programming in Java on the JVM, but by considering these other languages, we stand to benefit from them. Now, clearly, as enterprise developers, we are a little suspicious, we're a little cautious. We don't want to rock the boat. We don't want things to break and cause trouble for us, right? So we really are cautious. But I look at languages a little differently. I look at languages as they are vehicles for getting us around where we need to get around. For example, which is a really good vehicle is a question we could ask. But the answer really is, what do we want to get out of it? For example, in a given week, I ride my bicycle from time to time. I do drive my car, but I also have to fly in airplanes to get to places where I need to get to. So in other words, for transporting myself, I depend on multiple different types of vehicle. In a similar way, when developing applications, we could look at using multiple different languages to get around fairly quickly, if you will, and that can help us quite a bit to get things done fairly effectively. So how would we approach this particular concern to use these languages? Let's talk about that. Now, while there are several languages that are available for us to use, what are the predominant languages? Now, I want to be a bit careful about being predominant here, of course, and the reason is Java is the most predominant language today. If you want to look at the adoption, Java is the most prominent language, and when we say that other languages are prominent, there's a fairly large gap between those languages and Java itself. But ignoring the gap for a minute, the other predominant languages in the JVM are Scala, Groovy, Clojure, and JRuby. I would say these four are probably kind of competing fairly well in terms of more popular usage among people who are adopted to it and gaining some strength as well. So given some of these different languages, why should we consider one language versus another is a question that we want to ask. So I want to talk about some of the reasons to explore these different languages that are on the JVM. Now, what does Java provide? Let's talk about typing to begin with, because most of us have used Java and relied upon the static typing capabilities. But there's often a confusion between typing when it comes to what typing really means in these languages. So to understand that, let's understand the difference and the similarities between static typing and dynamic typing and strong typing and weak typing. It's often that people confuse dynamic typing with weak typing, which really is not true at all. So what is static typing? Static typing is where a compiler really looks for type information and verifies the type information at compile time. And of course, we all know that Java is statically typed. But on the other hand, dynamic typing is where either there's no compiler or the compiler is fairly relaxed that it allows the type information to be bypassed at compile time. Now, of course, it's a little scary, or a lot scary, if we have never programmed in a dynamically typed language, and we could say, how in the world can we get around programming in a system where type information is not verified at compile time? Sure, there is a disadvantage to foregoing the compiler check, but there is a benefit that comes from it as well, and I will argue that the benefit outweighs the cost if we have a discipline in how we write it. But let's not make a mistake and misunderstand static typing and dynamic typing with weak typing. So these two are orthogonal. On one end you have static typing, on the other end you have dynamic typing. Opposite to that, orthogonal to that, is strong typing versus weak typing. So what is strong versus weak? Strong typing means that your program will also be verified at runtime to make sure that the type information is actually correct. So in that sense, Java is both statically typed and strongly typed at the same time. I'm sure you have come across situations where you write your Java code, the compiler gets through it, but occasionally at runtime you get a class cast exception. How in the world do you get a class cast exception at runtime? That's because of the strong typing where the JIT compiler verifies that the type information actually is correct. Now, in the case of weak typing, it's garbage in, garbage out. There is absolutely no verification at runtime. Can you think of a language which is statically typed and weakly typed? Can you think of an example of a language like that? C and C++, that's exactly correct. What happens in C and C++? The compiler will verify the type for you, but you can cast away the type if you want to. And when you cast away the type, what happens? It produces the binary for you, and you run it, and if the type information is wrong, what does the C++ code do at runtime? The answer is we don't have a clue, right? You don't know what it's going to do. Will it work properly? Sometimes. Will it run? Most of the time. Will it crash? Well, if you're lucky, it'll crash in front of you. If you're not lucky, it'll crash when you're going to do this important demo, right? So we don't have a clue what it'll do, right? I mean, this is why, if you notice, C++ programmers are very eager to get to work in the morning because they want to know what their code is going to do today, right? Because you can never predict it. So that is an example of a language which is statically typed and weakly typed. Now, because the strong typing comes from the JIT compiler on the JVM, almost every language that runs on the Java virtual machine is automatically strongly typed. So Groovy is dynamically typed as against being statically typed, without referring to the static feature in Groovy. I'll talk about that a little later. But as a result of this, the language is dynamically typed and strongly typed as well at the same time. On the other hand, Scala is statically typed and strongly typed. Now, Scala is statically typed, all right, but Scala is more statically typed, by the way, than Java itself is. And the reason I say it's more statically typed is that Scala has a much powerful type system. It also deals with generics a lot better than Java does itself. And also Scala gives a very healthy dose of type inference as well. And we have our friend here to help me with the computer crash that I have. So please introduce yourselves, please.
Hello, my name is Yura.
Speak louder, please.
Hello, my name is Yura. I'm a software developer, I believe, and I will help you to see this presentation.
So please give him a hand and welcome him. So he's doing a great job. I'm going to hand over the presentation to him and sit down and watch him present the rest of the presentation. No, just kidding. Do you have Scala on the machine? Excellent. So, do you have Scala also? All right, let's kind of look at some Scala here. All right. Hey, this is even better. I like this. Let me a little bit. There you go. Excellent. So let's kind of give it a try. I've never used this machine, but I'm going to kind of see what we can do with it. I hope your machine doesn't crash like mine does. Okay, so he very nicely brought up the Scala REPL, by the way. This is awesome. Thank you very much. This is great. So this is one of the beauties of Scala is Scala, almost every language worth its salt today has a REPL, by the way. REPL stands for Read, Evaluate, Print Loop, REPL. And you can type in a little bit of code and play with it right away and get a feedback. So let's look at an example here. So I'm going to say var greet is a string, and I'm going to say this is hello, let's say, for a minute, right? So I defined a variable here called greet, and the value, the type is string, and I gave a value of hello for it. Yeah, that's great. But did you notice something kind of weird, isn't it? In Java, we normally say string greet over here, like this, right? And then equals hello. This is how we would do in Java, isn't it? Well, of course, with a semicolon, right? Now, we didn't do that in Scala. Why? Because Scala says the type information is only a little bit important. The name that you give for a variable is even more important. How many times have we seen programmers say string A, string B, right? That's not a good idea, isn't it? So this says it's important to give a better name. Now that I've given this name, I'm going to say greet equals, let's say, hi. And I'm giving a new value for this greet variable. And notice it was fine. It took it. Now, on the other hand, I'm going to say greet equals 1. Oh, dear, what happened? Notice it tells us I cannot give a value of 1 to this. And why is that? And the reason, of course, is because 1 is an integer. And I cannot assign a value, an integer, to a variable, which is a string. So that makes sense, isn't it? But notice that I defined this as, over here, as greet string equals hello. But I'm going to go back here, and I'm going to define greet2 this time. And notice I left out the type information. But notice what the REPL tells us. The REPL tells us that greet2 is actually a string. And this is because it has type inference. In other words, it infers the type. It says, notice that you assign the value which is a string. So based on this context, I kind of assume that it's a string. What else would it be? And so it figured out it's a string at this point, and so assigned the value of a string to it. Now, make no mistake, this is done at compile time. So Scala is not only statically typed, it is more statically typed, but also has a very healthy dose of type inference. So as a result, you don't have to put the type information as much. Now, if I go to this and say greet equals hi and change the value, but if I say greet2 equals 1, notice I get exactly the same compilation error as I did the last time. So there's a very healthy dose of type inference happening in Scala. And as a result, it did not require us to type the information. So when a language is fairly good, has a fairly good amount of static typing, you end up typing less with your fingers and let the compiler take care of most of the type inference for us, and that's definitely very healthy. So if you're looking for a language which is type checking at compile time, Scala has better type checking than Java itself does as well. So in other words, if you want to continue to play with a language which is statically typed, Scala is definitely a good option to look at because it provides you as much and even more type information and type verification than Java itself does. But what about dynamic typing though? Dynamic typing is where you let the language decide the type information more liberally at runtime. So I'm going to bring up the Groovy shell here. So thanks for having that in your path as well. And notice that this is a Groovy REPL that we have in this case. Now, similar to the Scala REPL, I'm using the Groovy REPL. And in this case, of course, I'm going to say in here, I want to specify a variable. So I'm going to say greet equals, let's say string greet equals hello. So Groovy is a little different, by the way, compared to JRuby. JRuby is fully dynamically typed, but Groovy is not fully dynamically typed. Groovy is optionally typed, meaning it's like a dial you can switch back and forth. If you don't want to bother with type information, change the dial all the way to the right, and you don't put any type information. Or change it all the way to the left, and you can specify as much type information as you would like to. So notice in this case, I set the type information to string, and I assigned a value to this. Now, obviously, I want to know what the type of string is, greet is, so I'm asking him what is the class information here. So greet.getClass, what is it? And of course, let's try one more time, print line, greet dot, I know the reason here. We are in a REPL here, so it's not too happy with it. Let's fix that. So let's use the world's best editor here, VI, how about that? Right, I don't care about what editor we have, other editors we have. We'll call it sample.groovy. So right there, all right. So what am I going to do here? I'm going to say string, so string greet equals, let's say, hello. And I'm going to say print line over here, right? Print line greet. And I'm also going to ask him to print the class information. So let's run groovy sample.groovy. And it tells us that in this case, it's a hello and it's a string class. So I'm going to go back to this code for a minute. I'm going to say greet equals hi, and I change the value here. And of course, I'm going to ask him to give me these two details one more time this time. Let's see what it tells us this time. Notice it tells us it is hi and the value is string. So this is optionally typed, but I've got a little quiz for you here. I'm going to say greet equals 1. What do you think is going to happen? Error, I heard. And I also see some people shaking their heads saying, no, no error. So let's find out what's happening. Let's print out greet. And you won't get an error, by the way. In this case, it printed a 1. You're a bit shocked, at least, right? What's going on here? Well, when you go back and take a look at this, you will be more surprised when I ask him what the class information is, by the way. And if you wonder what the class information is, what did we declare greet as, by the way? String, that's correct. And guess what? It is still a string. And you're like, darn it, what is it doing? It said, you gave me a 1, I'm going to bend over my back, and I'm going to make that 1 a string. So quietly it called the toString method under the hood for you. Now this is a bit strange that it did it, but it preserves the type information. But if I go back to this code, by the way, and remove this and put a def over here, now this behavior is different. Because I put a def, I am saying I don't want to specify what the type is. In other words, we are now in the dynamically typed world in Groovy. And as a result, I will print the value of greet. You can ask him what the class type is. It is a string because we assigned a string to it. I modify the value to hi. It'll print hi. What's the type, by the way? It is still a string. And then, of course, I assigned a 1 value. It'll print 1. What's the type right now? It's an integer. Because we did not specify what the type is up here, as a result, it will have a different type information as we run through it. So notice the difference. So this is a dynamically typed language with optional typing. Now, Groovy 2.0, of course, has static typing capability as well. So if you want to specify type information very thoroughly, you can do that in Groovy. And you can say, I want to statically compile this code, and that's possible. So it's even more statically typed and come fairly close to what Java can do with type checking, or even better at some points. So that gives us an example. So if you want to think about type information, if you will, think of the type information as static typing. All the languages on the JVM are strongly typed. So you don't have to worry about something like, Perl, for example, or JavaScript, where it's garbage in, garbage out. So everything is strongly typed. But then you can ask yourselves, do you want static typing or dynamic typing? And you can make use of it. So if you want to put a little chart of the values that you have access to, you can think about these as follows. You can think about these as the type information essentially being something along the lines of, if you are interested in static typing, Scala is definitely a very good choice. But if you're interested more in dynamic typing, there are a few choices for you on your hand. You got Groovy, you have Clojure, and you have JRuby. All these 3 languages, by the way, are dynamically typed. And Clojure and JRuby are fully dynamically typed, and Scala, of course, Groovy, of course, is this hybrid, optionally typed language. On the other hand, if you're interested in static typing, you got Java and Scala, with Scala being a better choice if you really want very powerful static typing available to you, right? So that is a way to think about this and see how you want to select it. Great. Let's continue a little bit further with this now. Now that we saw how we could look at typing, I'm trying to pull up a little example to show you how we can compare these things. I hope I will be able to bring that up along the way. So we looked at type information, and that is something we could select it. So what if you want dynamic typing, but why would you want dynamic typing? Dynamic typing kind of helps us to postpone certain decisions. And if you never programmed in a dynamic type language, it's a little scary. But if you are getting used to it, it can open up doors for some flexibility. We'll talk about what those things are as we go on a little bit further. Later, I'll get to those kind of reasons. So given this, what are the reasons we want to look at other languages? Well, when it comes to languages, there is something I really care about a lot, and that is called essence versus ceremony. Now, what is ceremony? Ceremony is what we have to do before we get to do what we really want to do. And ceremony really is boring. Anybody here who likes ceremony? That you want to sit all day and do more ceremony and ritual? No, right? We don't like ceremonies. We want to go out and have fun. We want to be productive. And ceremony is where we are required to do stuff before we get to do what we really want to do. Now, why is ceremony such a bad thing? Because ceremony can make us less productive. Let's think about this for a minute. Let's say we want to create a car class in Java. How would you create a car class in Java? You would do something like this, right? You would say public class car. And then what would you write? And then you would say private int, and then you would say year. Oh, you forgot to put final, didn't you? So you got to go back and add a final at this point, right? So you got to add a final, great. And then you would say private int miles. Are we done? Not really. We'll say public int get year. We got to write that also, right? And then you would have to say here return year. And then of course you would write get miles. And then here of course you would return miles. But you also need another method called setMiles, isn't it? And of course, what would you pass over here to this function? Well, to this function, of course, you would have to pass a variable. What name would you call it? This has got to be called as miles, like there's no other variable name, right? And then, of course, within here, you would then, of course, say this dot miles equals miles. I really hate this syntax. I can't tell you how much I hate this syntax. I want to strangle the people next to me if they write code like this. So a little bit away, please. No, just kidding. So the point really is, why is this such a bad idea, by the way? That's because this miles variable is hiding the member variable, the field called miles, right? And errors can creep into the code. This is a lot of effort, but we also have to write a constructor for this as well. How do you write a constructor? Public car. And then, of course, here you say int year. And then, of course, int miles, whatever the initial value that you want to provide. And more of this. This dot year equals year. And then this dot miles equals miles, right? So set the value of miles. Does it sound familiar to you? Anybody has written code like this? All of us, right? And those of us not raising their hands, they are saying, not really, Venkat. We never write this code. We write this code, then we gently right-click on that variable. And before we could blink our eyes, our IDE vomits the rest of the code for us, right? So not only do you want a language with a lot of ceremony, it has to come with IDE that constantly vomits. And who's going to deal with that vomit, by the way? And then we code like this, right? Because we have to deal with that vomit constantly. Like, why would we have to go through that kind of pain? Let's try to see how we could write this in Scala for a minute, and then see how we can take it from there. So this is, of course, the Java code. I'm not even going to save it. Let's try this in Scala, right? So let's go to Scala. By the way, how many times do you make your class not public? Most of the time it's public, isn't it? So simply say class car. Oh, is it public, by the way? Of course it's public, right? If you don't want it public, say, otherwise just move on. And then what do you say? You say val year integer, var miles, and then what do you say here? Integer. So right there, you say, wait, I want to define a getter for the year. Done. I want to define a getter and a setter for miles. Done. Oh, I want to write a constructor for the car. Done. I know you're getting really worried. You're thinking, what would I do with the free time now? Go home. Enjoy, have a good evening. You should never be at work writing stupid code, right? So look at the low ceremony. I hit return, and notice what it said. Define the car class. Now I say new car. Notice it gives an error. It says, how dare you are creating an instance. You haven't given me the parameters that are needed for this. It tells me you haven't given me the constructor parameters, right? Oh, of course, I'm sorry, I should give that. So I say val, and car1 equals new car 2013, comma, 0 miles. So it created a car object. Now I want to print over here, and car1.year, car1.year. Hey, where did that go? Oh, of course, this is Scala. So print line, and of course, I want to print car1.year. So, and then I can say print line car1.miles. So you can see how we were able to create that. You say, but wait a minute, what if I want to put methods in this class? So I'm going to go back over here to this, and I'm going to put a little curly bracket, and then of course I'm going to say define drive method, And within here, I'm going to say the miles, or distance rather, so distance is going to be integer. And what am I going to do here? Miles plus equals the distance, and we finished defining this car. Now let's create an object of car right here. So I'm going to say car1.drive 10, and now I can print the miles this car has been driven, and of course it's 10. Or we can also use a little low ceremony, and we can simply say drive 10 with no semicolon, no parentheses. And of course, now it better have moved 10 more miles, and I can see that it's 20. So you can see that in Scala, we have less ceremony. So notice what I did. I defined the car class, but I didn't write a lot of stuff. It generated a lot of stuff for us. Just like that, in same way in Groovy, by the way, for example, let's switch over here to Groovy for a second. So Groovy SH, and in Groovy, I'm going to create a class car, and in this case, I'm going to say int year. Let's make it final, by the way. Final int year. And then I'm going to say int miles. And of course, we defined a car class. It is public by default, even here, just like the way it is public and default by default. It also gives us a few interesting things for us. Like, what does it give us? It can give us a few things to make our life a lot easier. For example, in Java, if you don't write a constructor, Java compiler writes a constructor for you. In the same way, Groovy writes a getter for final methods for you automatically. And it also writes a getter and setter. Notice this. I'm going to say car1 equals new car. Let's say, just create an object right now. And I'm going to say well, what is the value that I'm going to set for this? So I'm going to say car1.miles equals 10. And it feels like I went in and I modified a particular variable over here. You know, how strange is that? But the reality in this case is I did not modify a variable at all. To the contrary, what I did is I actually invoked a getter method under the covers. So I could say car1.getMiles, and of course I can also say car1.setMiles, and then I can set the value, let's say, to 20. Now, where did that getter and setter all of a sudden come from? Well, let's think about this for a minute. We all have used Java Beans, remember? Well, when Java Bean was released, oh, by the way, Java Beans is a very sad story. When Java Bean was released, the very first day they released, they announced Java Beans. They said, we have new thing called Java Beans. And the Java Beans heard about it, came back and said, this is awesome. What am I? Oh, you're not just those regular Java classes, you're a Java Bean. And Java Bean went out and partied and drank all night and said, I'm special. And then it came back to Java and said, am I really special? Of course you are special. How am I special? And Java said, why, you are a bean, you have properties. And Java Bean went out and had more party and enjoyed it. And then it came back and said, how do people use these properties? And Java said, of course by writing those getters and stupid setter methods. And the beans realized this was a nasty trick played on it. And Java Beans have been in depression ever since. They've been on Prozac constantly. Groovy treats Java Beans with the respect they deserve. Did you notice we defined year and miles up there? Year and miles are not fields, those are properties. And we used the getters to access them if we wanted to, but when we didn't use that, what happened? It is still a property. If you're not convinced, let's look at this one more time, if you will. Let's go back over here for a second. Let's go ahead and define the car class one more time. So here's the car, and I'm defining the miles one more time. So right there is the miles. But this time, I'm going to say public int get miles, and within this method, I'm going to output print line you called get miles. And then, of course, I'm going to return the miles value that you want to see. So I define the get miles. Let's also define void set miles. And of course, in this case, the miles is what I'm going to take, integer the miles. And within this, of course, let's go ahead and define what am I going to do with this method. So I'm going to say print line over here. And let's say you called set miles, right? And what am I going to do in this case? I'm going to say miles equals the miles. And I've set the value of miles. Let's close this now. And now let's go back and say car1 equals new car. And I'm going to say car1 dot miles. And notice what it did. It automatically called the get miles method for us very quietly, didn't it? How does it know to do this? It is because miles is not a field, miles is a property. And as a result, it automatically called the get miles method. You could call it directly also if you want to. Nothing stops you from doing it. But a call to car1.miles also brings you the access directly to the get miles method, as you can see. In the same way, when you say car1.miles equals 20, you are automatically calling the set miles method as well, as you can see in this case. So the point really is that you are not forced anymore to have to go through the ceremony one more time, and that's basically what we are seeing here. It's low ceremony, and that definitely is a very good news, isn't it? So that is basically what we are seeing here is low ceremony all the way through. Now, a way to think about this is, if I can bring up this file, let's actually kind of try to do this. So let me pull up this file here. So let's eject this. So if my friend will help me to bring this file over, there's a HTML file in there that you can pull up. And let's kind of do a little evaluation on this and see how that's going to look like. So here's the way I want you to think about evaluating which language is good for you. So just bring up that rate.html and double click on that, and then just bring up that file, open that file, and then let's go ahead and take a look at that HTML file. Assuming I have done this fairly well, we should be able to see that. There we go. Don't worry, your machine is 1,000 times faster than mine today. It is opening something else. Let's open that file. Yeah, there we go. Awesome. Thank you very much. So what I'm going to show you here is a way to kind of evaluate these languages. And if you notice what I have in this case, let me, when you're looking at things, oh, by the way, before I go further, I want you to think about how do you make these evaluations. The very first thing I would say is you want to leave your emotions at the door. Because the first problem with picking a language is when people get emotional, our brain doesn't work properly, right? And then we are kind of really eager to pick one language versus another. So drop your emotions. Don't be prejudiced about it and say, I'm going to reasonably evaluate which language is a right choice for us. So I have this, by the way, I'll post this tonight for you. You can play with this. And what I have in this is a little HTML page. And static typing is the first item we talked about, right? And I have a little scale here. I'll enter the value in the scale in a minute. And I have a weightage here. What is the weightage for? If you are working on one application, let's say, you are building a library which requires very good performance and type checking in infrastructure, I would argue you want fairly good type checking, right? But on the other hand, if you're developing a layer of application where you want DSLs, domain-specific languages, you want fluency, you don't care as much about type checking. You can ease a little bit on it. So the weight that you see here, I want to think of how much importance you are giving for this particular feature. In your application, you could, by the way, you could give a high weightage for both static typing and dynamic typing if you have to. Why would you do that? Because your application may have parts where static typing is very important and parts where dynamic typing is very important. Or you may work in an application where you don't care about static typing. You can give a 1 or a 2 or a 0 for it, or a 5, and give a high number for dynamic typing. Am I making sense? right? The weightage simply is a knob you can vary to decide which is more important to you. So let's just, since we have a partner here to help me with this crime, you're going to help me. Think of a hypothetical application. How important is static typing for that hypothetical application? In a scale of 0 to 10. Pick a number. You can ask for help if you want to. 10. 10, okay, 10. So we give a 10 value for this, right? So I gave a value of 10, and notice that these numbers became 50 right now. Why? Because I've given the same value for all of these. Let's fix it. What would you say is from scale of 0 to 10, how effective is Java in static typing? So I heard 6, somebody say 6. That's a little too harsh. 10 is too liberal. Something between 6 and 10. 8, all right. Java 8 doesn't change a whole lot, by the way, in that regard. What about closure? How strongly typed is closure? 0. All right, what's the next one? Groovy, what do you think? You said 5. Why did you say 5? Because you can vary the options. You also have static typing if you want to, right? So I would actually give it about, let's say, an 8 for this. Because you can implement static typing if you want to, as much as in Java, if not more. Actually, more also. What about Scala, by the way? What would you give? Oh, JRuby, how much would you give? 0. What about Scala? How much would you give? 10. It's as statically typed as you can ever get. So now if you go over here and take a look at it, this only on this, by the way, if that is all you're going to look at, notice what happened. You rejected closure and JRuby, right? And of course, in this case, these are the numbers we got for these languages based on that. So far, so good? What about dynamic typing? In this hypothetical application we are talking about, what would you say is, how important is dynamic typing? And remember, you could have same number for both or variable numbers, depending on parts of the application. Just pick an app. What would you give a number for dynamic typing? 5. 5. 5. Okay. So how dynamic is Java, by the way? What would you give? 0. That's correct. Oops, 0. What about Java 8? No difference. What about closure? It's as dynamically typed as you can get, isn't it? What about Groovy? Absolutely, you can get as dynamic as you want. And JRuby as well. And Scala, what about Scala? Well, you could say 0, but they're playing with dynamic types right now. Let's give it a 2 for now. And do you still want to keep the weight at 5, by the way? Okay. Now what does it tell you? If that is all you're looking for, it tells you that the languages you probably want to consider are Java and Groovy. That's what it says, right? Again, this is purely hypothetical, right? And you can vary these numbers and see which one may make sense. Okay, great. Let's go to the next one. Low ceremony. Anybody wants more ceremony? Not really. So what do you want to give for the weightage for ceremony? A 10. A 10 is a little too harsh. 7? Okay. What did you say 3? I'm going to walk him out. Just kidding. No, 3 is too low. I agree. All right. Okay, that's fair. Is it okay if I give it 3? It's low ceremony, not high ceremony. So it's got to be other way around. You want Yeah. So if you say 7, you are tolerating a little bit of ceremony. If you say 3, you're tolerating, that's where its difference is. You're on the right, you're okay. You're still friends, that's okay. Yeah. All right, so that is 7, that's good. Java, what would you give? Three, 5? 5. Okay, so here's what I would say. I would say, maybe I would say 2 for this, and maybe I'll say 4 for Java 8. Java 8 does, eliminate a little bit of ceremony, right? All right. What about closure, by the way? Ignoring the parentheses. I would say, let's say 8. What about Groovy? Oh, come on. 8. What about JRuby? What about Scala? 9. I would still give it an 8 for now. So now what did we see here? Now if that's all we are considering, right? It tells us maybe we should look at Java 8, Groovy. Groovy becomes a major contender now, and then maybe JRuby. Again, these are just numbers for you to vary, right? Hypothetical and based on what your application needs are. That's all you're looking at. All right, so I talked about the low ceremony aspect. Let's talk about functional style of programming. What is functional style, by the way? Functional style is something that makes our life a lot easier by writing more expressive code. Now, we are used to writing procedural code. We're used to writing object-oriented code. But in functional programming, we do things a little differently. Remember structured programming versus procedural coding. What did good old Dijkstra tell us? Dijkstra said, go-tos are evil and you should not use them. Remember that? Well, does it mean that there's no go-to at all? That's not true. There is go-to in the code after you compile it. We just don't use go-tos in the code we write. In the same way, structured programming eliminated go-to, functional programming eliminates assignments. So you're writing an assignment-less programming. Now, it may appear strange. How could you ever write a code where there is no assignments? That's kind of a bit strange, isn't it? But in the beauty of this is you can write code with no assignments, and pure functional languages give you that. The second thing about functional programming languages is that you use what are called higher order methods. What are higher order methods? Do you need to interrupt?
I have a question about
Yes.
break.
Ah.
Мы паузу делаем или без перерыва идем до конца? Что? Давай, 10 минут тогда. Быстренько пауза. Yes, break.
You want to take a break?
Yeah.
Okay.
Take a break, 10 minutes.
10-minute break it is. All right. Sounds good. See you in 10 minutes.